When we talk about a z-score, it's actually bringing in some things we've been calculating for the past couple of days. A z-score basically lets us compare a score, like a grade maybe you get on something, versus everybody else. And not just like, hi, I got an 80, oh, hi, you got a 75, oh, I did better than you did. Not that way, but in seeing, in relation to the whole group, where are you as far as scores go? So to find this z-score, here's our formula right here. We're going to take whatever score you got, we're going to subtract the mean or subtract the average score, and then divide it by what the standard deviation is. And what this is going to allow us to see, if we get a negative answer, is how far out, how many standard deviations are we below the mean or below the average. So in other words, if I was looking at my chart and I find out that I'm 1.3 standard deviations better than everybody else, it means I'm in a pretty rare category here. Like I'm in the top 15% or so of all the scores that are there. And it gives you a truer definition of what it is you've achieved or what you need to work on a little bit. So if it's negative, it means I'm a little below the average. And if I get a positive answer, it means I'm above the average. But normally, okay, what we deem normal, kind of a data distribution, is between -2 and +2 standard deviations. So basically, if you're in that 95% that's in those two spaces, you're in the normal category of things. So it's somewhat hard to be abnormal, I guess, I'd say, with this part. So the first example here we're going to talk about, I've got worked through for you, but then we're going to work through a couple together so you can see how this works. So our first one, how well did Sarah perform in her English literature coursework compared to these 50 other students? Okay, so here's our information. Sarah scored 70 out of 100, and the mean score was 60. You're like, well, right there, if the average was 60, she got 70, she did better. But how much better did she do? And the standard deviation was 15. So if I were to make a drawing of this, kind of a bell curve like we did before, the mean score was 60. So that would be the score that's in the middle. As I stretch out from there, so as I go one standard deviation to each side, I'd add the 15 this way, I'd subtract the 15 the other. So this would be like a -1 and a +1 as far as my standard deviations go. And if I went out another, I'd go up 15 to the right, down 15 to the left, and that would get me 2 standard deviations out. So standard deviation is really a part way of saying how many do I go out before the next chunk of data gets taken care of. So when we start to look at this, we go, okay, so Sarah scored 70 out of 100, so she's going to be somewhere over here, it looks like. So for me to figure it out, to actually get her z-score, so I can make a comparison, I would take her score, 70, minus the mean, or minus the average, 60, and then divide it by the standard deviation. And I'm going to be giving you this information. So it's not like you're going to have to calculate all these things. Even though with the calculator, if I gave you everybody's scores, we can get the mean and standard deviation with a couple of clicks of the button on the calculator. So we do all this calculating and we get this 0.667. Well, what does that mean? Well, this 0.67 means she's slightly higher compared to everybody else. Now, depending on what the scores are, that could be big sometimes or it could be small. And that's why we got to take this into perspective that way. Because let's say instead the standard deviation would have been like 5 or something. Then she'd have been great. I mean, she'd have been like 2 standard deviations and way out here. So it's why we got to take everybody into perspective and not just, you versus one other person or maybe 2 other people. So now we actually get to play with one of these. Okay. Lewis earned 80 on his biology midterm and a 71 on his history midterm. In the biology class, the mean score was 75 with a standard deviation of 4. In the history class, the mean score was 73 with a standard deviation of 3. Convert the scores to standard z-scores. Okay, we got 2 separate things going here. So we've got biology. So I'm going to get my biology here. We're going to do that first. So if I'm doing my z-score, remember, it's my score. So my score is 80. Minus the mean. So the average score in the class was 75. And I'm going to put this in parentheses because if I go to the calculator and I don't do that, I'm going to have an issue. We'll look at that here in a second. With a standard deviation, that's what I divide by a 4. So, and I'll show you why the parentheses are important. Let me show you what would happen the first time if I didn't do that. And I'd hope you'd have a little bit of logic to say something don't seem right here. Like, wait a minute, my z-score is 61, so I'm 61 standard deviations better than everybody else. Yeah, no, that doesn't make any sense. So instead, that's much more sensible. So basically, what we'd be saying at this point is if we're comparing Lewis to everybody else, and we're kind of trying to look at that graphically, he's at 1.25. He's out here somewhere. So he's better than a pretty good chunk of people. He's not out in this elite area, but he's definitely pretty well above average, and it lets me see that versus everybody else. Now let's see if that happens when we get to history class. So history class, same idea is working. He got a 71 on his history exam. In history, the mean score was 73. Uh-oh, we're a little below that. With a standard deviation of 3. The formula is never going to change. So I jump in, and I go, okay, well, let's see here. So he got a 71. The mean of the class was 73. Standard deviation was 3 points. We see our first negative. Now, is that terrible? No. Not terrible at all. Because negative 0.67 doesn't even get me to this negative 1 part. We're still pretty close to the mean or the average. So compared to everybody else, he's pretty normal. But whenever I'm trying to figure this out, which test did he do better on? Well, I mean, bio. Well, how do you know? I got a positive z-score. Wherever you find the largest value, that's always where you're going to find the betterment of yourself. Now, of course, if they're both negative sometime, we want the one that's closer to 0 because it's not as bad. But that's the type of information I can dig out and get from these. So, again, we may not always be given everything directly. That happens a lot in here, but that's okay. A normal distribution of scores has a standard deviation of 10. Find the z-scores responding to each of the following values. A score of 60 where the mean is 40. Okay, so if I have 60, the mean is 40, and they told me up here the standard deviation is 10. So I can type that in, or this one I think I can do in my head. 60 minus 40 is 20. 20 divided by 10 is 2. Now that's a big one, because now we're 2. Okay, this z-score means I'm 2 standard deviations over. I've outscored whatever this is, like 97% of the people that are taking this or doing this. That's a big deal. So we'd want to take a look, what was that person doing? How's it working? But sometimes we got to dig a little bit. A score that's 30 points below the mean, does that mean I'm going to use 30? No. What score am I going to be using? 10, because here, the mean is 40. 30 points below the mean means 40 minus 30, which is 10. So 10 minus my mean, ooh, this is going to be not so good, over 10. So if I crank that out and get it in the calculator, ooh, 3 standard deviations to the left. There's going to be very few people that did worse than I did. So maybe we need to take a peek, was there something going on outside? What's going on that makes that happen? So, one more kind of peek here. I found this one, I just couldn't resist. IQ scores have a mean of 100, so that'd be average, and a standard deviation of 16. Albert Einstein reportedly had an IQ of 160. What's the difference between Einstein's IQ and the mean? Okay, 60 points, or 60 IQ points. How many standard deviations is that? Well, the difference between his IQ and the mean is 60. Divided by 16. Okay, Albert, how smart are you? Compared to everybody else, that is. Wow. Okay. And we actually just did convert his IQ score to a z-score. Because what did we do? We took his score, 160, minus the mean. 160 minus 100 is 60. And divided it by the standard deviation. So his z-score is 3.75. Whoa. Think about this for a minute. His z-score puts him almost out to 4 standard deviations. There's like minuscule point something people that IQ-wise would be smarter than he is. So that's how it lets us compare people to the other. Is it usual or unusual? Unusual. He's way smart. Those are the types of things that we can use to actually find this. So, what's that mean I'm going to do? That means I'm going to have you working on something like this other sheet. Now, there's one problem on here I want to do. Because I've got a couple on here that are unusual, but they work the same way. But I want to make sure we're okay with it. So on the actual z-score worksheet, just to get you thinking a little, we're going to go down to number 4 because it's a little different than some of the other ones are. So I get down to here and I say, okay, a highly selective university will only admit students who place at least 2 z-scores above the mean on the ACT that has a mean of 18 and a standard deviation of 6. What's the minimum score the applicant must obtain to be admitted to the university? Okay, this is applicable to us. So you're like, okay, now the formula is score minus mean over standard deviation equals z-score. That's important to keep in mind as I'm doing this because they're not giving me the same information they did necessarily when we were going through on the notes. So I notice at least 2 z-scores. So, okay. So I have what it equals this time. This is kind of weird. Above the mean on ACT that has a mean of 18. Okay, so I'm subtracting 18 from something. And a standard deviation of 6. What's the score that I want this time? That's the mystery value now. So it's a little different than just popping it into my calculator this time and saying, ooh, I'm done. No. I have to solve this like I'd solve a regular equation with the understanding of the formula. So I'd go through and I'd say, okay, well, I'm going to solve this like I normally would. I want to get rid of the fraction. Multiply by 6 first to get that out of there. And now I'll add the 18 over. So the minimum ACT score this university is going to take is a 30. Notice nowhere mentioned in there is a 30. So on some of these, you can't just go brain dead repetition. You're going to have to look at it and say, okay, this is still the formula I'm going to use, but what information are they giving me that I can go ahead and calculate this? Sometimes you may even have to do it twice in a problem, depending on what it's being asked for. Last thing I'll do to help out, then I'll try to get out of the way. Number 5, I'm going to help with setup. Okay, the average for the statistics exam was 75. The standard deviation was 8. Andrew was told by the instructor that he scored 1.5 standard deviations, but that's not the one I want. Flip over. Sorry about that. It's number 7. Knew it was the pharmaceutical one. Okay, pharmaceutical company wants to test a new cholesterol drug. This type of stuff actually goes on in businesses. The average cholesterol of the target population is 200 milligrams and has a standard deviation of 25 milligrams. The company wished to test a sample of people who fall between 1.5 and 3 z-scores above the mean. Into what range was the candidate's cholesterol level be? Okay. Two separate situations here. 1.5 and 3 z-scores. Same idea as what we were doing on the last one. So I look and I say, okay, average, mean, cholesterol is 200. Okay, so let's see here. The mean is 200. Okay. Standard deviation is 25. Okay. The company wished to test a sample. Well, how do I do between 1.5 and 3? You know, this is kind of crazy. I'm going to run it on two different equations. My mean's still going to be 200. My standard deviation's still going to be 25. But I'm trying to figure out where my lower and my upper scores are going to be. This is going to give me my range. Once I calculate this, this is going to tell me the lowest cholesterol somebody's going to have. This is going to tell me the highest cholesterol somebody's going to have. And it gets me the range or the cholesterol level that you need to be involved in this study. And that's what we're looking for. But again, you have to think. It's not just going to be straightforward every single time. Sometimes it may, sometimes it may not. So use this, apply this, and it'll kind of give you some help even as you're trying to figure out some of the values with your normal distributions and your empirical rule.